Okay, my name is Brendan Gongol, and this is RBIF 111, Biomedical Statistics with R. I'm going to be your instructor for this course. So I'm just going to give you a brief introduction to myself, who I am, how I moved into the field of bioinformatics, and perhaps a little bit about my hobbies and whatnot. So I actually started out my career in the pre-hospital setting, worked as a paramedic for about 5 years. That's how I put myself through college. And then after that, I actually worked in ICUs at a local hospital. I'm located in California. And I did that for about 3 years. And I found that I was really curious about how the human body worked and how the therapies that we were delivering people were actually functioning. And so I decided to pursue a career in science, and I graduated several years ago with a PhD in biochemistry and molecular biology. And during my graduate program, the projects that I was working on heavily integrated biomedical sciences as well as informatics. And so that was my first exposure to R and some programming languages, and then how to utilize computer science to be able to answer really important biological questions. So after I graduated, I took a teaching job at one of the local universities, and I was actually assistant professor, and that was a teaching position in the Department of Cardiopulmonary Sciences. It was a multidisciplinary position that involved medicine, informatics, as well as some hard science. So I've taught actually a diverse set of classes, ranging from molecular mechanisms to diseases and their clinical applications. And then also informatics was always a platform in those teaching classes. Then when I finished that, when I finished teaching, I actually left that position and I actually pursued a little bit more intensely my research interests. And I was a research fellow in the School of Medicine, the Cardiopulmonary Division, and that was at the University of California, San Diego. And I did that position for about 2 years. And now I'm currently at the University of California, Riverside at the Institute for Integrative Genome Biology. And I work on the High Performance Computing Center there. And our goal is to be able to answer biological questions, specifically how small molecules interact with biological systems in order to derive new drugs and therapies that really affect the translational impact of a lot of the science that's done in the Southern California area. So when I'm not pursuing my career, actually, I enjoy playing soccer and running on the weekends. That's kind of how I deal with stress. So what's bioinformatics? Well, for me, bioinformatics has some molecular knowledge, molecular biology information. That could be a lot of science knowledge, and also how science relates to healthcare. I believe that those two disciplines are heavily interrelated. It involves mathematics. That includes analytical thinking, statistics, and approaches. And that's a lot of what we're going to focus on in this class. It also involves some computer science, and we're going to get into this a little bit in this class as well in terms of algorithms, how R operates, and how to use R to be able to deploy mathematical models and statistics to be able to answer biological questions. But in computer science, it's also relational databases and the various aspects of computers that we utilize to be able to actually perform those mathematical models. And then something that's less talked about in bioinformatics is the leadership components of the field. One of the things that attracted me to bioinformatics is that this discipline, being a multidisciplinary field, is really core to all sciences. And also analyzing all data. And what that means is that as a bioinformatician, we are at the foundational level in terms of understanding what the data is telling us and provide direction to other researchers on how they can most likely maximize their success with experiments and careers and whatnot. So there's a lot that goes into leadership. Trust and honesty. People have to have confidence and trust that the analyses that we're doing are valid and that we're actually conducting science appropriately. We have to have confidence in ourselves, and there's a lot of different aspects of leadership that really go into the actual communication of the results that we identify. So the importance of bioinformatics, a lot of my job is involved in integrating genomic data sets and we utilize high performance computing platforms. And also we do a lot of, say, consensus sequence mining or mining of different biological sequences, integrating with machine learning and whatnot. And we do that using R and Python. We use some bioconductor libraries and BioPython libraries to be able to elucidate disease mechanisms or pathways, and then ultimately utilize that for things like translational applications, that is translating information from the bedside to the clinical setting, or it could be precision medicine itself. So in our course goals, we're actually just going to have an introduction to R and use some introduction to a lot of the statistical techniques that we utilize. And so this course is really driven towards understanding those fundamental key important aspects of bioinformatics or data science that you're going to utilize in many of your analyses or projects that you're involved in. So I look forward to meeting everybody in this course, maybe sharing my experiences with other people and also learning about other people's experiences, as well as answering any questions that you guys might have. I'm available. My email address is listed on this slide. And my office hours are also listed in the course syllabus, but I'm really available most of the time. The best way to get a hold of me is to just send me an email. So I think we're gonna have a great time in this class, and I'm looking forward to getting to know everybody.